Welcome back to our final session of the Boston HPC Digital Roadshow. We are now into the panel aspect of our event. Joining us today, we have got David Power, Consultant Head of HPC for Boston Limited, Chris Coetzee, who is our country lead for South Africa for Boston, Matthew Foley joining us from AMD, Andrew Addision from the Boston Enterprise Solutions Group, and Glenn Rosenberg, who joins us from vScaler. Hello everyone, and thank you for joining us. You might all want to unmute at this point.
Hello, Maz. Good to be here.
Hello, Maz.
Yeah, good to be here.
Hello, Maz. Thank you very much.
So, Chris, did you want to kick off by just summarising the last week that we've had? While I line up some questions here from our attendees.
Sure. Firstly, before I get to that, special thank you to our sponsors for this event. Without you guys, this wouldn't have been possible. And I think it's been a very successful week. We've been able to sum up what Boston is able to offer through our partners, through our vendors strategically. And yes, we've had some exciting opportunities already presented to us through a couple of partners in the market. We're engaging with 1 or 2 universities already, so thank you to you guys as well. Yes, I think it was a great event.
Chris, this is one for you. How does Boston Limited fit into the channel?
Well, that's a great question, and it's a question that we are quite often asked when we're engaging with customers. So we understand and appreciate the value of the channel in the industry. So we do make use of the channel. We are ultimately regarded as a distributor, so we do engage very actively with our partners in the partner space. But ultimately, we love our customers, so we do engage relatively actively in the end user space to make sure that we get our message across effectively. We do this in collaboration with our partners, but effectively it's quite simple actually. We engage with end users, but we don't sell directly to them.
Okay, and are Boston's offerings available throughout Africa?
Absolutely, 100%. So again, this is a very good question. A lot of our customers in South Africa could be regarded as the capital, if I can put that unarrogantly. A lot of head offices that are based throughout Africa are situated in South Africa. So we are offered to engage at head office level in South Africa and service the regional offices throughout the African continent directly from South Africa. So we are able to offer support in 54 countries in Africa, up to 4 hours mission critical. One of the benefits of engaging with Boston as well is there's a logistical benefit. We can ship directly into any country into Africa without coming into South Africa first. So there's a lot of benefits on that side.
Fantastic. This is one for you, Glenn. How easily can vScaler scale?
Yeah, that's a very simple one to answer. The answer is very easily. And it can scale in a manner that will allow you to implement whatever technologies that you're looking to add to your estate. One of the joys of vScaler and the vScaler software platform is that it can make use of all of the different types of technologies and all of the different types of architectures that are available in the marketplace.
And another one here, is vScaler flexible with its choice of CPU?
Yes, it is. And yeah, it's nice to see AMD back in the fray alongside Intel. I have a great respect for them as a processor provider and love Intel as well, but it's brought back a balance into the CPU marketplace. And dependent on the number of cores that you're looking to use or the performance, there is a raft of different technologies that you can now select. And vScaler is agnostic and will happily use all of the technologies.
Fantastic. Question for Andrew. Andrew, we've talked a little bit about yourself and Taylor being part of the Enterprise Solutions Group. Could you just give us a lowdown of, who are the Boston Enterprise Solutions Group if people haven't come across you before?
Well, we're a very small team, and we've obviously integrated completely with the rest of Boston. But it's Taylor DeKine, me, Andrew Addison, and we got Ryan Taylor, who's with us, and Chris Constant. And yes, so that's basically it. We're a very, very small setup at the moment.
And you'll be supporting across the business. So if any of our customers, kind of need the support of the Enterprise Solutions Group, you guys can be brought in like knights in shining armor.
Well, I don't know about shining armor. I'll have to check my cupboard, but yeah, we're there to help bring it in. That's basically it.
Fantastic. And I'm just checking down our questions here. How can people, this is one for you, Chris, what is the next stage for our customers if they want to start dialogue with us? Maybe they're at the beginning of their HPC journey.
Well, the best would be is to get in touch with us either through our website, or we can put my details, we can send my details to them. But ultimately, the first step is discussion for us to scope out what the requirement is. As I've mentioned numerous times this week, we love our customers. We love engaging with them. We love being part of their journey. So I think David mentioned it earlier as well. The earlier we come in, the better. So the first point of contact would be through our website. Get in touch with us, have a technical discussion, test if you want. We love letting our customers test in our laboratories, and then then we like holding hands with our customers through the journey.
And Dave, what technologies do we actually have in our labs at the moment?
So I may need to be careful here, as we have some of them which are unreleased and perhaps are under NDA, but suffice to say that there's pretty much every CPU architecture that you could ever want to test if you were working on enterprise workloads. We've got 200 gig InfiniBand fabrics to ensure that we've got incredibly high inter-process communication and access to back-end storage. We've got an array of combinations of Optane, DIMMs, NVMe drives, storage technologies and solutions. And a lot of our team are actually very well versed in terms of spinning up different parallel file systems and scale out storage products on top of these technologies, so that regardless of what protocol or back-end storage platform you're looking to run with, we can have something set up there. And we've also actually got a small little vScaler set up in the lab as well, so people that want to come in and test workloads across, be it containers, virtualized or bare metal systems, we can accommodate that. And again, we've access to a lot of commercial software and the know-how around kind of tunneling for external license servers. So if you needed to come in and bring in applications that are not readily available, our guys can work with your team to ensure that they're installed, working, and ready for use as well. So yeah, it's a great little play pad for techies and engineers. I'm using it myself at the moment for a couple of customer benchmarks at the moment. So yeah, once that's up and ready, it's ready for people. Actually, the other thing we had the pleasure of unboxing there the other week was the DGX A100. I know that these are few and far in between in the field at the moment, so that's one of the latest arrivals I think we've had in the lab, which is got a fairly big queue on there. But certainly, if people are interested, please get in touch with Chris and the team, and they can get your slot booked in.
And am I right in thinking we've got some of the AMD high frequency CPUs in as well?
I'm pretty sure we do. So I know I'm certainly testing on the 64 core procs at the moment with a certain customer. And I'm pretty sure we have some of those F-series CPUs knocking around the lab as well. In fact, I'm pretty sure we've got every CPU combination that's available in the range. So yeah, we've been very happy with the partnership with AMD, and there's huge demand out there in the market from end users to come in and understand and test and evaluate how it works with their applications. So yeah, they're certainly available as well.
So I've got a question that I'm going to throw out to everyone? You know, we saw, you know, even 5 years ago that there was quite a defined line, you know, where HPC started, but we're now seeing that you know, HPC dribble into, you know, other industries and markets. How are we going to see HPC evolve, or are we just going to just have one large market now?
I'll make a stab at starting with that, Maz. Yeah, I mean, from my own personal experience, I mean, I came from, I guess, an academic sort of background, and it would have been, you know, a lot of the earlier customers we would have engaged with would have been research labs and universities and, you know, government organizations. I think with the explosion of, you know, people essentially adopting digital technologies to run a lot of their workloads and simulations, spanning right from, you know, life sciences through to, you know, the rendering that I'm watching with my children who are watching Pixar movies, you know, all of the underlying technologies that are being used here, you know, could in effect have been deployed as HPC systems. With the adoption of, you know, running services as services and AI workloads, they're sort of bringing us into new territories that I guess we previously wouldn't have been in. So you start to look at retail and security, and pretty much anywhere that collects information. I mean, data is the new gold, it's the new currency in the world, and extracting value from that is pretty much impossible based on the amount that's being generated. So you need additional tools and techniques that can help you get through that, extract value and meaning. And this is where, you know, large scale data storage, fast processing, and, you know, tools and techniques to extract that meaning from it. It is kind of, you know, playing a critical role across enterprise. Combine that with the advent of, you know, containerization, and people starting to run workloads and services on top of Kubernetes, and people from the HPC space also adopting a kind of a containerized approach in terms of application mobility. And you know, if you were to look at a kind of a Venn diagram, I can kind of see, you know, what was HPC and where enterprise is going, and they're sort of merging together. And this, you know, this middle section is where there's a lot of really interesting things happening that are bringing in, you know, parts of AI and parts of HPC and parts of enterprise together.
Yeah, I think David's correct in that summary. The other thing that's going to drive the merging of HPC is customer workloads, and with edge computing starting to take off in a big way, and artificial intelligence, you really have the need for both low power and high power computing all in the same bundle. So it's going to merge even more. An HPC will become something that will be employed whether on a fixed term basis per customer, or whether it will be used in the cloud. It will be part and parcel of everyday computing for every business that's running.
Fantastic. Anyone else to add on that?
I guess what I can say here from the semiconductor space is that we now see the opportunity to optimize more aggressively towards different workloads than before. If you think of the chiplet architecture that we have, you know, not everything in there needs to be a CPU core, for example, or we have different kinds of technologies that you can put into these types of solutions. And the you know, as we move forward and accept more and more heterogeneous computing, there's even more of an opportunity to tune the deployments towards the problems that are being solved. And so I think what we're seeing is a fragmentation of a formerly general purpose market, and that we'll wind up with more and more special and specific solutions for given problems. So we already see that to some extent. You know, different SKUs fit different workloads a little bit better or worse, and so we try to optimize for that. But I see a whole world of more and more application specific hardware solutions for these problems.
Fantastic. Next question. Is HPC just all going to move into the cloud?
I think there'll be a balance. There's still a lot of cost involved in moving large amounts of data, in various costs that aren't always visible when you're moving data across different domains, across different geographies. and there is often a need to have the data with most or alongside your processing power. So I think that HPC will always have two very clear merging paths, but will blur every line going. The cloud is essentially a different way of working rather than a place or a thing. And cloud abilities within HPC is now possible. HPC within cloud is now possible. So the two will coexist for a long period of time to come. And the different styles of work that people have requiring the different types of technologies will guide some of those selections. So you'll have the workload, you'll have the budget, and you'll have the available technology that will guide where the customer will ultimately place his data, rather than just this: do they have a cloud policy? Do they have an on-site policy? I think there will become a lot more smart customers selecting multiple types of workloads and where they're placed.
Yeah, and just to extend even on that, I mean, Glenn's hit the nail on the head there. You know, cloud is becoming a very useful utility for pretty much all workloads. But from, I mean, experience with one of our customers who's actually been running their HPC infrastructure 24/7 for the last 3 years, they've observed quite a significant cost impact to actually running that. I think cloud is an incredible utility, and with the, you know, if you're able to leverage small things like, you know, spot instances and just be able to burst out to it as and when there's, you know, good offers in place, or when there's loosely coupled workloads that are a good candidate to be migrated out, I think ultimately it's going to form part of most organizations' strategy in terms of, you know, delivering cycles. So everyone is going to have a cloud strategy. But yeah, when you look at large scale, tightly coupled jobs, it's still more cost effective to run them on premise. But our technologies like vScaler actually have this cloud burst capability built into it. So it kind of puts control back in the user's hands in terms of, you know, where they run their workloads. So if it does make sense for, you know, projects that have perhaps come about at a very short notice without having the resource capacity in place, you know, being able to actually push workloads out to the cloud in a matter of minutes is an incredibly valuable capability for a lot of organizations. You know, as Glenn said rightly, when you're starting to move, you know, many petabytes in and out of the cloud, it gets very expensive. If you're running large scale, tightly coupled jobs, they can actually perform quite poorly. So you do need to kind of understand the characteristics of your applications and understand where cloud does make, you know, sense for each individual organization. But certainly the tools to help you do that and make it transparent and, you know, help you try and avoid being locked into any one cloud vendor is certainly something that needs consideration, and that's what we've been putting together with the vScaler platform as well.
Okay, we've seen liquid cooling at supercomputing trade shows for years and years, and it's not really been perceived to be embraced with enthusiasm. Is it possible to effectively embrace liquid cooling in the data center? How are warranties affected, and, you know, what kind of reliability can you expect, and maintenance as well? Andrew, maybe this is one for you to kick off with.
Yeah, well, I can't really comment on the warranties. I understand that obviously if you're going to dip a board into some oil and something goes wrong, or you want to replace it, I can imagine that being quite a tricky scenario. In terms of how green energy's taken hold, I think that rethinking what a data center actually is probably going to be the way it's going to go. And then I think it's easier to have the likes of liquid immersion as part of that story. So an integrated energy management, for instance, and using the waste heat and so on and so forth, as I was talking about earlier on. So how it changes shape, I don't know. I mean, traditionally a data center, you have a large building and then they put the computers in and you've got air cooling and blah, 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 blah. When you rephrase it in terms of energy in a city or something like that, then you're going to be talking about how a miniature silent data center actually fits in a community and how the energy can be reused in different ways. It's a more complex, holistic discussion, I think, really, but I think it's heading in that direction, if that that answers your question.
Dave, do you have anything to add?
Yeah, I mean, I think there is a continuing trend in terms of power density. Most legacy data centers would be air cooled, and they may have augmented additional liquid cooling capabilities into the environment, but they were only ever really, spec'd up to cool somewhere between 7 to 15 kilowatts in a 42U rack cabinet. I think if you look at the kind of densities and, with TDPs increasing across the board on CPUs, accelerators are becoming more commonplace. They in themselves can consume nearly 300 watts per accelerator, nearly 200 watts for an individual CPU socket. Stick 4 GPUs, 8 GPUs, 16 GPUs into a box with a dual socket server, and you can easily hit 60 to 80 kilowatts inside in a rack environment, and it's physically impossible to cool that via air cooling. So liquid cooling will become commonplace. I think it is commonplace in high-end HPC deployments that we do. And I think we'll see that trend continuing to develop over the next couple of iterations of technology as we continue to see power densities increase within the data center.
Matt, do you have anything to add to that? Because you're coming at things from a very kind of different perspective.
Yes, and I agree with the other statements. Really, as power densities go up, the efficiency of air cooling simply won't suffice, and so we do see a lot of demand for immersion cooling as well as demand for liquid cooled chassis. We see more requests, to us to go ahead and turn up the power because we're going to have liquid cooling anyway. To create SKUs for that environment. So, and that for us, that's a SKU definition question as well, right? Should we go ahead and make these 280, 300 watt parts? Our GPUs go up that high. We wouldn't be going there if we didn't have proper cooling solutions to be able to cool them. So we definitely do see that. We do see that going forward. And the liquid cooling, certainly is much more efficient in terms of getting the actual heat off of the components.
Fantastic. I like this question a lot. What innovation are you most excited about in the future of HPC? Matt, we'll start with you.
For me, it's a fairly straightforward one from us coming from AMD. It's really the combination of parallel computing into this environment of heterogeneous computing and making this an easier to program and easier to use combination. Now that for us is, I think, the trend that we're betting on. It's the trend that we see going forward. It's clearly driving the growth of accelerated computing today, and we have some experience with it. Partly from the client side, right? If you think about it, we do produce systems today which have CPU and GPU in the same package and even on the same die for laptop and desktop parts, and so we know how to do that. And the key is really how do we get the programming models available in order to do that, because there's clearly a lot that we can unlock in that trend.
And then maybe I can chip in here as well, man. So from my side, I think there's a couple of really interesting directions that the whole industry is taking. First of all, I'm very excited with how software is actually maturing at quite a rapid rate to be able to keep up with all of these technological innovations, to really extract the maximum performance and maximum flexibility from the hardware technologies that we're providing. I think, a comprehensive software stack is becoming more and more important. I'm also quite excited about, the idea around composable infrastructure. So, this is where you take this concept of being able to map devices across the fabric to dynamically reconfigure a system that's most suited to the workload. So, being able to attach NVMEs or GPUs, or perhaps in future being able to actually carve up and allocate memory and CPU cores to applications, so that instead of having this, consistent building block and fitting your application into that building block, you'll be able to request a hardware configuration in the future rather than just requesting cores and memory. And I think that's going to, become quite exciting. And then finally, I'm kind of, really excited about a lot of the areas that we're starting to kind of work in. In the last, 2 or 3 months, I've been working with organizations ranging from the telco space, life sciences, Formula 1 teams, and large rendering farms. And this is quite diverse in terms of applications, and it's helping to broaden my own knowledge of industries as well. So I'm looking forward to continuing to see HPC's expansion into other verticals as well.
I think one of the things I'm really excited about, I'm from a software engineering background for the last 30 years or so, is graph execution being handled in hardware at a high level. So basically the hardware becomes advanced and starts doing some computer science constructs on it. So all sounds a bit complicated, but if you normally with a GPU, you're doing general computing, and so you generally have to redo your algorithms to work in these kind of general cases. But now we've got TPUs, we've got IPUs, and ways of executing these things much more efficiently, which sort of fits in with the narrative of the machines running quicker and actually using them more efficiently. So rather than just doing a simulation of something, you can do a little decision tree, which means things like natural language processing and many other things like that. I think is going to be absolutely massive. I'm really looking forward to that. So there's companies like GraphCore that do these type of technologies in conjunction with the type of hardware that we have, as it Supermicro stuff and things. I do think there's a very, very big world going to open with more specialized kind of hardware, but as part of a unique, ubiquitous hyper-converged infrastructure.
Glenn, have you got your?
Well, I'm pretty excited every year within the HPC environment. I think we've seen technology come on leaps and bounds, and AMD set some new standards in some of the CPU processors. We have companies that are merging at a very high level that will likely integrate different pools of technology to allow us to move data faster, to access that data within both memory and within the CPU much quicker. So I think we're probably at the point at which we're waiting to see what happens from there. And I'm old and I've been around in IT for over 30 years, and technology tends to be cyclical. It's like everything. There's a 10-year cycle as to which way the technology is moving and which way the business is moving, and I think we're at the start of another cycle, which will be good for customers. The thing that's absolutely obvious is the ability to do something with customer data is going to be absolute key to driving value from compute, and that will be the thing that will drive most of the decisions that businesses will make in 2021, and that's both from a commercial point of view but also from a research point of view. And we're involved, our technology is being used, as is AMD, I know for definite, in a lot of the COVID-19 research. And this type of research that becomes a more global gathering of technologies and companies all helping towards drive goals for the good of mankind will continue to move technologies and compute forward, both software and hardware. So I think we're at a very interesting point in technology, and I'm really looking forward to edge computing starting to generate data that can really be used in a very efficient and informative way.
And Chris, do you have anything to add?
No, not from my side. These professionals have pretty much summed it up.
And kind of talking about edge computing, I mean, that seems to have been, AI was kind of a hot topic last year. It all seems to be about the empowered edge, the intelligent edge this year. What are your what are your kind of predictions for how the empowered edge is going to evolve? Because right now, you know, we're seeing kind of edge and AI at the edge in, you know, certain places. Are we going to just see that explode in the next 5 years, 10 years? Where do we think it's going? Dave, maybe I'll start with you.
Yes, sorry, I was scrambling for my mute button. So look, I mean, I think it's kind of just the natural cyclical nature of technology. If you look at where, you know, supercomputing was 20 years ago, like one of these phones was probably as capable as the fastest supercomputer in the world. And if you kind of project, you know, forward another 10 or 20 years, you know, we're going to have that same capability. What can you do with an exascale capable system when it fits in the size of your hand? And it's this, you know, continuous improvement and in computational technology that's making edge more suitable. I think you combine that with, you know, the likes of 5G networks, which are coming online, and suddenly we have this ability to send huge amounts of data to and from lots of devices. And this is going to create all new sorts of opportunities across, you know, verticals that, you know, perhaps even haven't been created just as yet. But it's certainly an exciting time. It's still, you know, it's that classic grid or distributed architecture, but taken to the next level. And yeah, there's going to be a lot of exciting new innovations in that space over the coming years as we start to see those networks get rolled out and we start to see, you know, users start to interact with their devices in different ways.
Yeah, very much agree with that, David. The thing that will drive edge computing is customers understanding what they can use the compute at the edge for. And it's a little like, you know, we're probably a couple of years behind that same problem that AI had, which is what do you actually use it for? And then once customers and companies understand what they can actually use it for and derive value from it, that's when you'll really start to see it take off. But 5G is absolutely essential to its success. Otherwise, it will become something similar to, yeah, some form of edge monitoring rather than what it has the ability to become, which is real, you know, low-level, high-performance computing at the edge of the network, which can be fantastic, and it will also be supremely essential for autonomous driving.
Does anyone else like to add to that? I think you've summarised it there in a nutshell, Dave and Glenn. So before we wrap up, I am going to ask a very simple question to each one of you. What is your favourite piece of technology? It could be something that you use every day in your life, or perhaps, you know, it's something you do as part of you use as part of your job. Glenn, because we have you on the screen, I'm going to start with you.
I have an Alienware computer, which is liquid cooled, which is the best computer I've ever had. And that is my favourite piece of technology at the moment.
Matt, I'm going to cross to you.
Gosh, yeah, it sort of puts me on the spot there, I guess. Normally, I like to look outside of the industry that I'm in and to find that, and some of the real innovations in the automotive space, especially around battery technology. I think that that area, along with the advances in renewable energy, that really holds, you know, significant promise for changing, changing just the way that we work and live. And then when you combine that with the edge technologies that they mentioned as well, you know, you're talking about autonomous cars that run on, you know, long-lived batteries. So I'm really excited about the you know, from what I can see, some of the innovations ongoing in the transportation sector. I think that has a real opportunity to change, you know, the way that we change society for the better.
Fantastic, Dave.
Well, I would like to say, Maz, this is very unfair because you didn't prepare any of us with these questions at all. Just come up with some magic on the spot. So I'd like to call you out instead. But one of the technologies I use the most that I genuinely get excited about is just my little terminal here on my SSH client. Now, I know it's very dull, but suddenly it becomes the most required technology that I have on my machine just to get from place to place. So like this morning I was working on a system out in South Africa, and it was like I was locally attached to the system here because of my little SSH client. So the fact that we're becoming far more connected, I'm very excited about a lot of these remote working technologies and how, even though the situation we're in, we try and extract some of the benefits from it. And I think, thanks to the technological breakthroughs that have been made around, screen sharing, working remotely, being able to do conference calls, team meetings, live chats. I mean, these technologies get me quite excited. Also within my family, there's a huge debate going on at the moment about Xbox or PlayStation. So that's also kind of gaining a lot of cycles over the dinner table here as well, over which platform will be the most exciting to come with. But perhaps I'm going off piste a little with that, even though they are, I think, using AMD chips internally. So
I think that's very relatable for our audience.
What's your favorite technology, Maz?
Well, mine's more like looking to the future. So I think autonomous vehicles are the things that I think are going to be the most revolutionary. Just thinking about friends I have with disabilities. I've got a friend who's not able to drive because she's partially sighted, and at the moment she has to rely on buses and friends to drive her around, and it restricts her professionally and personally. So I think thinking of elderly people, you see some people that perhaps are driving cars that shouldn't be driving cars on the road at the moment, and I think the advent of autonomous vehicles, it's going to give people more freedom and hopefully make the roads safer, you would hope, but I think we have some way to go. But I think that's what excites me most about the future. I mean, of course, I could talk about my iPhone as well, but who have we got left? Chris, Coetzee.
So I think my technical head in country might shoot me for what I'm about to say, but I'm a big fan of automated accessories in the house. So switching the light on and off from anywhere in the world. I've got a Google Nest here, and a lot of the things in my house are currently automated. I'm currently busy going down the route of having my irrigation system automated, but there's nothing out there that stops a 1-year-old puppy from chewing it. So I love IoT. I love being able to operate my house remotely, putting on lights on and off, seeing cameras, garage doors going up and down without me clicking a button. So that I'm a big fan of that side of things.
Andrew, I don't think we've come to you, have we?
Yeah, I want to thank everyone for giving me plenty of time to think about some stuff, by the way. Echo Dave's comments, I think, really. Well, I'm a bit of a dyed-in-the-wool geek, so I'm never far away from a soldering iron. But I suppose that in terms of what I need and love on a daily basis, unfortunately, it's going to be something rather dull like my iPad, like you're saying with the phone stuff. But there's two things which I'm really fired up about, actually. I've got a TPU, a Google TensorFlow processor, which you can just plug into a Raspberry Pi, and it's remarkable what it does. So you can plug into my Raspberry Pi, pointed at a fruit, an orange or something, and it goes, "Hey, that's an orange." And I still can't get over the novelty of that one. It's an amazing bit of neural net kind of stuff in your pocket, and it uses next to no power. It's very, very exciting. And I suppose the other one is, which I quite like, because I've been involved with it for about a decade now, is 3D printers. I've designed quite a few. And I like tinkering about with, I like Delta printers. I think they're amazing. So, in fact, I'm going to be playing around, getting my thing working tomorrow, so it auto levels itself. So, the idea of doing manufacturing just by putting in code and actually having something physically happen is incredible. Working with software to actually see you can create something physical is exciting. And I know that robotics in the future, especially with people who have got disabilities and stuff, and electronic assists, as it were, robotic assist for balance and going up and downstairs and things like that, is going to be an amazing piece for the future.
Fantastic. I think I ran through everyone, didn't I? I haven't left anyone out there.
I think they run off.
I think I've scared everyone away. Well, I think you'll be pleased now. I'm not going to fire any more questions at you. So thank you very much to you all for joining us this afternoon. We appreciate you giving up your time to present during our HPC Roadshow and lending your support to our panel discussion. Thanks to our sponsors, AMD, the Centre for High Performance Computing, NVIDIA, Supermicro, vScaler and the Boston Training Academy. Without you, we couldn't have carried out this digital HPC Roadshow. As I've mentioned before, all of our sessions are going to be available on demand. We also have the Boston podcast. And I have a feeling that actually this discussion would make a great podcast. So you might be able to re-listen on the Boston podcast, available on Spotify and all your other major podcasting platforms. So thank you to you for joining us. Make sure that you click on the email we're going to be sending you this afternoon, and you can input your passwords that we've been giving out throughout the show. We're going to be having training delivered by the Boston Training Academy tomorrow.